Hi everyone, welcome back to the channel. Today we're tackling an important safety topic, catamaran stability and escape hatches. What happens if your catamaran capsize and how do you get out? I'm going to explain why some multi-hulls need escape hatches, what the international standards require, and critically the whole real-world safety concern you need to know about.
Can a modern cruising catamaran actually flip over? Yes, but it's rare. To understand why, let's look at how stability differs between monohulls and multi-hulls. Engineers measure stability using what's called a GZ curve. It shows how hard a boat tries to return upright at different heel angles. A monohull GZ curve typically shows positive righting moment well past 90 degrees, and in many designs even near inversion, due largely to ballast keel weight. This means many monohull can recover from knockdowns under favorable conditions. However, self-righting is not guaranteed and depends on factors such as angle of finishing, stability, downflooding opening, damage and sea state. Multi-hulls, by contrast, exhibit very high initial stability, but a limited range of positive righting moment. Once heeled behind a critical angle, often around 70-80 degrees, the righting moment becomes negative, and after inversion they have little to no inherent ability to self-right. Think of it this way. A monohull is like a weighted toy that always pops back up. A multihull is like a wide, stable raft, incredibly hard to flip, but once it goes over, it stays over. So what could cause a multihull to capsize? Extreme weather conditions, particularly large breaking waves that can roll the boat behind its critical angle, or very strong wind with too much sail up. There's also pitch bowling, somersaulting end over when running downwind in very heavy seas. With proper seamanship and appropriate sail reduction, the risk is very low. But because it can happen and catamaran won't self-right, safety standards require certain boats to have escape provisions. The international standard ISO 12217 Part 2 determines if a multihull needs an escape hatch based on stability calculations. But first, you need to understand design categories. These categories aren't about where you sail geographically, but about the wind-wave conditions the boat is designed to handle. Category A, wind force exceeding 8 on the Beaufort scale, significant wave height of 4 meters and above, that's wind over 40 knots and serious seas, excluding hurricanes and rogue waves. Then category B, wind force up to and including 8, waves up to 4 meters, sustained winds around 30 to 40 knots. Category C, wind forces up to 6, waves up to 2 meters, winds up to 27 knots. Category D, wind forces up to 4, waves up to 0.3 meter with occasional half-meter waves. Winds up to around 16 knots. Now, not every catamaran needs an escape hatch. The requirement only applies to habitable multi-hulls susceptible to inversions. Boats with enclosed accommodation that are close to minimum stability requirement. A catamaran or multi-hull is considered susceptible to inversion if any of the 3 conditions are true. First, if the boat transverse righting lever that is resistant to rolling sideways is less than 135% of the minimum required for its category. This measures how well it resists being rolled by waves. Second, if the boat's longitudinal righting moment, its resistance to pitch bowling and overend, is less than 135% of the minimum required for its category. Third, if the wind speed at which the boat needs to reef its sails is below the threshold of 25 knots for category A, 22 knots for category B, 19 knots for category C, and 16 knots for category D. If any one of these applies, the boat is on the edge of stability requirements and need an escape provisions. Catamaran have slightly different criteria, with highest thresholds at 180%. There are 4 approved options. A dedicated escape hatch, purpose-built for emergency exit, a fixed panel with removable sealing strips and bead, a breakout panel with special tools stored adjacent. For categories C and D only, a normal access opening reachable by short underwater swim. Location requirement depend on category. For design category A and B, when the boat is floating in the inverted position in calm water, the highest edge of the mean of escape opening shall be at least 0.2 meter above the sea surface. Thus, part of the escape opening may be underwater when the boat is inverted. For design categories C and D, when the boat is floating in the inverted position in calm water, the highest edge of the mean of escape opening shall be less than 0.4 meter below the sea. The hatch must be openable from inside and outside, meet size requirements, have footholds for climbing when inverted, and when the boat is upright, be positioned well above the waterline to prevent flooding during normal sailing. Here's where this gets serious. What I'm about to share is based on documented public records, official manufacturer recalls, and publicly reported incidents. Escape hatches, while potentially life-saving in a capsize, can actually become a serious danger to your boat in normal sailing conditions. Several catamarans have actually sunk because of failed escape hatches. Let me give you documented examples. In September 2018, a Fountaine Pajot Helia catamaran named Marita was lost off Morocco due to escape hatch failure. Around the same time, another Helia had to jury-rig a system to pull their failing hatch close to reach port. A third owner had their lens pop completely out. These incidents have been publicly documented by the boat owners themselves. The problem was with Goiot brand escape hatches, installed in multiple French catamaran brands: Bali, Fountaine Pajot, Lagoon, Nautitech. The design flaw was catastrophic. The acrylic lens was attached to his metal frame using only silicone adhesives. When that silicone failed, the lens detached, leaving a large opening in the hull. Manufacturers issued interim security kits with adhesive strips, but these proved inadequate. Boat owners developed their own mechanical fixes, drilling through the lens and frame to install bolts. In January 2020, Goiot issued a formal product recall. This is a matter of public record. The recall advised owner not to use their boat until they reach replacement hatches. Think about the engineering challenge. You're putting a large opening in your hull in areas seeing significant water pressure and wave impact. That opening needs to remain absolutely watertight for years in harsh marine environment. Salt water, UV exposure, mechanical stress, everything works against these closures. The current standard, ISO 12216, sets water tightness requirement, but many believe these aren't strict enough for category A. There's work underway in the ISO working group to develop stricter test requirements for escape hatches in Area 1, the highest risk category.
To sum up, yes, catamarans can capsize and won't self-ride like monohulls. Whether users need an escape hatch depends on stability characteristic and design category. This determined by engineering calculations. But here's the critical takeaway. Escape hatches are a double-edged sword. While they provide an escape route in the rare event of capsize, they also introduce vulnerability that has caused real boat to sink in normal condition. This emphasizes the importance of proper specifications, installation and rigorous maintenance. The industry recognizes current testing standards need strengthening, particularly for ocean-going vessels, and work is underway to address this. If you own or are considering a catamaran or multihull, understand this design category, know its stability characteristic, check whether it requires escape provision, and if it does, they treat those hatches as critical safety equipment, requiring regular inspection and maintenance. Check for recalls and ensure required work is completed. Safety at sea is about multiple layers: good design, quality hardware, proper installation, regular maintenance, sound decision making and appropriate skills. Based on documented incidents, we know of significantly more cruising catamaran lost to escape hatches failure than to capsizes requiring their use. This doesn't mean they're bad idea. In principle, it means execution and testing standards haven't been adequate. I hope this has helped you understand catamaran stability and escape hatches, while highlighting critical safety considerations. If you found this useful, please like and subscribe. Drop your questions in the comments, and if you own a catamaran with escape hatches, share your inspection and maintenance routine. A note about professional compliance services. If you're concerned about escape hatches requirement, stability compliance or CE marking for your product, or if you're a boatyard needing expert guidance to RCD compliance, I'd like to mention my consultancy, Blue Peter Marine. We specialize in regulatory compliance, CE marking, RCD compliance and Model B and F, implementation services for boatyard and technical documentation support. We've also developed free online tools at www.ceinspector.com to help boat builders and surveyors with compliance calculations. You'll find calculation for stability assessment, downfloating angles, buoyancy requirement, and other technical calculations required under the ISO standards. These tools are designed to make compliance work more efficient and accurate. With decades of experience in the marine industry and deep expertise in ISO standard, we help boat builders, owners and boatyards navigate complex marine safety regulation. Whether you need professional compliance, assistance, or want to use our free online calculators, visit ceinspector.com or get in touch. Links are in the description below.